In this video, I will explain quadratic functions. I will show you different characteristics of parabolas. We will graph parabola, determine quadratic functions minimum or maximum value, solve problems involving a quadratic functions minimum or maximum value. So we will start with the standard form of a quadratic function, which is, this is a standard form of the quadratic that I'm showing you right now. A x minus h whole squared plus k, and a is not supposed to be equal 0. Okay, this is the standard form of the quadratic function. Now in this one, the vertex, this h and k is the vertex, so this h, that k is vertex. H is an x value and k is a y value, like that, like an order pair. The parabola, if a, this part, if a is greater than 0, then the parabola opens upward. Okay, parabola opens upward means it's gonna go like concave up, like this. So it's gonna open up. If a is less than 0, then the quadratic is concave down. So we would know how this a works, and then we will decide how to graph that. Okay, how do we graph quadratic functions with equations in standard form? There are a few steps that I usually use to graph quadratic using a standard form. First one, you have to decide, I'm going to write here my first step. First step, you have to decide whether the parabola opens upward or downward, which means you have to look for a is less than, a greater than 0, or a is less than 0. So you have to pay attention to that. If that's the case, so we would know if it's upward, this is going to go up, and that's concave down, and that's concave up. So we have to look for that. Then we will, the second step, we will determine the vertex. And like I said, the vertex is the h and k. And then we will find x-intercept. The third step, we will find x-intercepts and y-intercepts. X-intercepts and y-intercept. So we are going to look for that. And you guys should know that x-intercept means when y is always 0. And y-intercept means when x is always 0. So this is kind of order pair that I always write with my x-intercept, y-intercept. So I have it in front of me and I don't forget. Okay, so let's try the example 4 and using all that information that we just learned. This is example number 1. It says, they said graph the quadratic function, which is f of x equal negative x minus 1 whole squared plus 4. Now, if you guys pay attention up here, this is my k. This is my h. Now, what is a? It's right here, which is invisible 1. So I'm gonna write it down, all my stuff. A is equal negative 1. And we know a is less than 0, which means my parabola is gonna be concave down. And h is equal 1, and k is equal 4. So my vertex is 1, 4, and that's my vertex. So I'm gonna write here, that's my vertex. Okay, now let's try, that was the two steps that we just did right now, like we looked for that and then we found the vertex. Now we have to look for x and y intercepts. So here we go for the x-intercepts. X-intercept means, this is my equation, f of x equal negative x minus 1 whole squared plus 4. This is my original equation, and I'm looking for x-intercept first, which means the y is going to be 0. and I'm going to go back and show you x-intercept when y is 0 right there. So I'm going to make a y0 equal, and this is negative x minus 1 whole square plus 4. All we are trying to do to get this x by itself. So what I'm going to do, I'm going to subtract this 4 both sides. This is the first thing I would do. They cancel. Then I'm left with negative 4 equal negative x minus 1 whole squared. Now what do I do to get this x by itself? In order for me to get the x by itself, I have to get rid of this exponent first, and this is just a simple PEMDAS. So to get rid of exponent, we are going to do the square root. But once we do square root, I have to get rid of this negative. And we can multiply negative both sides, or we can add, we can divide negative both sides. It will be okay. So if I multiply negative both sides, so I can get rid of these negatives, then it means I got positive 4 in x minus 1. Okay, this x doesn't look good. X minus 1 whole squared, and turn positive, right? So this negative and negative turn positive. This negative and negative turn positive. Now I'm done with this. Now I have to get rid of the square root. So I'm going to square, I'm sorry, not the square root. I have to get rid of the square, so I have to do square root. 4 is a perfect square, so I got 2 equal x minus 1, and you know this and this cancel out. They are opposite operations. So I have to add 1 both sides. So I'm getting add 1 both sides, I think. Oh, I got positive negative 2 actually. I'll take this back. I'm not doing add 1 right now. I got positive and negative 2 because of the square root. So I have to get my x value. So what I'm going to do, I'm going to have x minus 1 equal positive 2. You add 1 both sides, and it will give me x equal 3. They cancel. So this is one x-intercept, and then I have to have another one because x minus 1 equal negative 2. So that will give me x equal, when I add 1 both sides, it's going to give me negative 1. So that's my another x-intercept. So I have 2 order pairs. I got vertex. I got my, I know it's concave down. So another thing that we just found, the x-intercepts, and it's 3, 0, and I got negative 1, 0. So this is all the information that I need for this to graph the parabola, in the one they gave me in the standard form. So that's my x-intercepts. There. Now we have to look for y-intercepts. So I'm going to go and look for y-intercept. My y-intercept means when I have x0. So this one is going to be like easy, I think. I have f of x formula. F of x negative x minus 1 whole squared plus 4. So I got f of x equal, and plug in 0 for x. Okay, so this is going to give me negative 1 plus 4 equal f of x. Then it's going to give me 3. So my y-intercept is 0, 3. So I'm going to go back and write that information up here, which is my y-intercept, and it's 0 and 3. So I got all the information right there. All I have to do now is plot the points and see how my parabola looks like. So let's see. This is all the information. This is all the information that we have, and I'm gonna plot the points. It's upside, it's a concave down from the parabola, we know that. What is the vertex? 1 and 4. So this is 1 and 4 is my y value, 1, 2, 3, 4. So my point goes right there. That's for vertex. Now I have x-intercept, which is 3, 0. So I got 1, 2, 3, 0, and I got negative 1 and 0. Here we go. Then I got y-intercept, which was 0 and 3. 1, 2, 3. So these are all my points. All I have to do is connect them and see how my parabola look like. I mean, it's not straight, but that's all I can do. Here we go. So this is my parabola, and that's the graph of this. Now, if you have the vertex of, if you have different, like this was the standard form of the function. Now if we have different form, which will look like f of x equal ax squared plus bx plus c. So this is another form of the parabola, the equations that we get. So what do we need for this to graph the parabola? Again, the same things we're gonna need. We have to, let me pull this down. So I can use it for graphing, and I can move that one down all the way here. Okay. So I'm just going to move that just a little bit more so I can have all the information. There you go. So that's my function, ax squared plus b, and usually we see that kind of parabola equation. So this is what I have. Now, what do I need to figure it out for everything? I need, again, the same thing. Step one, we have to look for a. If a is greater than 0, then it's concave up. If the a is less than 0, then it's concave down. We have to look for this a if it's negative or positive. Now, what else we need? We need the second step. It was vertex, right? For vertex, I want to use a different color for vertex. Okay, I'm going to use this color for vertex. I'm sorry. Okay, I'm going to go back because it's erased everything. The first step, we look for a greater than 0. It's going to be concave up. A less than 0, it's going to be concave down. Then the second step I have to look for vertex. And in this case, the vertex is not, it doesn't look like HK form, like a standard form. So the vertex formula is negative b over 2a. That's the x value you're going to look for. And the y value is going to be, you're going to plug in this x in the function, and you will get the y value. So this is what the vertex we're going to get. Then we have to find the same x-intercept and y-intercept. I want to use a different color for this. So we are going to use find x-intercepts, which is the y is always 0, and we look for y-intercepts. It's the same steps that we did for the standard form. Y-intercept means the x is always 0. So these are the 3 steps again I'm gonna look for. So let's do example for this. And my example is going to be in this color, or maybe let's do the white one. Okay, so my equation is f of x equal negative x squared plus 4x plus 1. Now I'm graphing this. So what is the first step? If it's concave up and down, and you can tell a is 1 invisible, which means it's concave down. So I already know this is concave down. In the information I'm going to collect, I'm going to make a box here, and this is all the information we're going to write here for the graph. So my vertex, my parabola, my function, my a is less than 0. So it means, which means negative 1. So I have to have a concave down parabola. Okay, next, vertex. Find the vertex. And the vertex formula was negative b over 2a. This is for x, to look for x. So plug in negative b. b is 4, right? So minus sign goes in, it's 4. I know this is a, that's b, and this is c. We already know that part. So that's negative 4 over 2a. What is a? Negative 1. Negative 4 divided by negative 2 will give me positive 2. So that's my x value for the vertex. How do I get the y value? Because I need an order pair for vertex. I'm going to plug in this 2 in the original equation, which is right there, and it will give me my y value. So let's plug that in. I'm going to have f of 2 equal negative 2 squared plus 4 2 plus 1 right there from the top. So negative 4 plus 8 plus 1 is going to give me 5. So this 5 and 2 are my order pairs. So what is my vertex? My vertex is equal to 5. So that's my order pair. Third step, x-intercept and y-intercept. So let's find the x-intercept first. For the x-intercept, I used a yellow color, so I'm going to use the same yellow color. The x-intercept right there, I have the equation which is f of x equal negative x squared plus 4x plus 1. And I am going to make the y 0. X-intercept means when y is 0, right? I just put the order pair there. So I got negative x squared plus 4x plus 1. Now, if you guys pay attention, this is a quadratic. I can do factor and get the answer, but this is a really weird parabola, because if I multiply 1 times 1, this is these, you know that for factoring, we have to find 2 factors for 1. And when we add or subtract those 2 factors, we will get that 4. But there is no way I can get something that I can add to 4 or subtract and we get 4. So 1 times 1 is the only 2 factors for this. 1 plus 1 is going to give me 2, not 4. 1 minus 1 is going to give me 0, but not 4. So this is kind of, like I said, a weird parabola, like I can't factor out. Then I'm going to use my quadratic equation, which is x equal negative b positive negative b square minus 4ac. Now guys, if you cannot solve the quadratic formula easy way using your factor, then use your quadratic formula, which is this one, and you have to memorize it. So we know this is a, that's b, and that's c. So I'm going to plug in all the values to get that x. B is a negative sign. This is going to stay. B is 4, positive, negative. In the square root, I have b squared, which means 4 times 4 is 16, minus that 4. My a is negative 1, and my c is positive 1. This is c. Over 2 negative 1 is my a. So let's solve this. It's going to give me negative 4, positive negative 16 plus 4 in the square root over negative 2. When I solve that further, negative 4, positive negative 16 plus 4 is 20, square root 20, over negative 2. Now, since it's positive negative, then I have to have 2 answers. So what I'm going to do, if you guys pay attention here, I would put in the calculator positive first, like negative 4 plus square root 20 over negative 2. Put this in the calculator and you will get answer negative 0.2. And when I do the minus 1, which is negative 4 minus square root 20 over negative 2, this is going to give me approximately 4.2. So what are my x-intercepts? My x-intercepts, I'm going to write there, x-intercepts that I have, one is negative 0.20 and another one is 4.20. So these are my x-intercept. Now I have to look for my y-intercepts. I have to look for y-intercept. Y-intercept means when x is always 0. So let's plug in x up here. And I'm going to show you, after I'm done with this, I'm going to show you, instead of doing, or if you are allowed to use a calculator on the test in the classroom or your teacher lets you use it, and I'm going to show you when you plug this in right there, after this you can use a calculator. Then I'm going to show you how I'm getting, without doing all this work, how I'm going to get 0.2 negative and 4.2. So I'll show you that. But let's try and figure out the y-intercept. Y-intercept means when x is 0. So I got negative 0 squared plus 4 0 plus 1. And this is going to give me 1. So my y-intercept is 0, 1. Let's see. My y-intercept is 0, 1. Now I'm done. All I have to do is plot the points and get the graph. So here is my graph. Okay, here's my graph. Let's try. First thing, I know it's upside down, and I'm gonna go for vertex, which is 2 and 5. So that's 1, 2, 1, 2, 3, 4, and 5. Here we go. That's my vertex. It's in purple. Then I have x-intercept negative 0.2, which means it's right there. I'm approximating. It's negative 1 is right here. The negative 2 is supposed to be up here somewhere. Then I have 4.2. So 1, 2, 3, 4.2 is somewhere here. Then we have a y-intercept, which is 0 and 1, which is right there. All you have to do is connect the dots. And this is your best approximation right there. So that's how the graph is gonna look like. Now, like I said, I'm going to show you how to do the your calculator. Use a calculator after this, and you will get your negative 0.2 and 4.2. So I'm going to show you how to graph all of that, okay, using a calculator. Now let's go to the calculator. I'm using this calculator. This is my TI-84 plus C. I will try to focus it. Okay, and here we go. Now, I already graphed this, but I'm going to show you how to graph it like from the beginning. So let's clear everything, Now, go back. Okay, turn it off too. So I'm going to show you how we do all of that stuff. Okay, it's off. You turn it on, then you will be here. Then you go to X, you go to Y equal right there. Then all you have to do is graph the equation, which was, my equation was negative x squared. So my negative is going to be this sign, okay? That's negative. X is right there, and square right here, negative x squared plus 4x plus 1. Now, I already said that like when you make this equal 0, then that's where you use a calculator. So the next equation that I have on the other side of equal was 0. So what I'm doing, this is one side of the equation, that's another side of the equation. And all I'm doing, I'm gonna find the point of intersection for these two. And those point of intersections are my x values, like x-intercepts. So those are gonna be my x-intercepts. So let's graph this, hit graph. You see the red line is 0, and this is my parabola right there. So now I'm going to figure it out, these 2 points of intersection. And if you guys remember, using a quadratic equation, we did get 2 x-intercept, negative 0.20 and 4.20, right? So you can see these are the 2 points of intersections. So these are my x-intercepts. So I'm going to find x-intercepts exactly what it is. You're going to go to second and calculate. So it's going to go to 5, intersect, enter. You see the blinking thingy is right there on the top. You can move this down here. That's my point of intersection. And you can tell right there, I can zoom in and you would be able to see it perfect. So you guys can see right there. I didn't use the first curve, second curve or something. I just moved the cursor here. And it's going to give me negative 0.2. We rounded up to negative 0.2. So that's my first. Then I have another one. I'm going to move my cursor. And this is my 4.2. So these were the two that we had, and that's how you're going to figure it out using your calculator without solving, if you're allowed to use a calculator. So this is how you find your if the quadratic equations, and if you need x-intercepts or you need point of intersections for some reason. Okay, let's go back to our okay, now we got that, we finished. Now let's talk about the maximum and minimum first. So from the quadratic equation, what is maximum and what is minimum? Now let's see, you guys pay attention here. We will consider this equation, okay? F of x equal ax squared plus bx plus c. Now you guys pay attention really closely to this one, because this is the one, the maximum and minimum, which we call it absolute maximum and minimum in calculus. So this is going to help you in AP calculus if you're taking it. Now if we have, now I'm going to give you the hint, if a is greater than 0, then it means the parabola is concave up, right? Like this, we know that part. If it's concave up, a is greater than 0, then it means this parabola has a minimum. Okay, if I have a less than 0, then it's concave down. If it's concave down, you can tell it has a maximum. So this is maximum. Okay, and the minimum and maximum always occurs at vertex. So wherever is your parabola vertex, like negative b over 2a and f of negative b over 2a, like the x and y values. So wherever is your vertex, that's your maximum and minimum. But if it's concave up, that's minimum because it's in the bottom, and that's on the top, so that's maximum. That's the only thing you guys should remember that. Now, I'm going to give you a few examples here. Look at this example. I have f of x equal 4x squared minus 16x plus 1000. Now, without graphing this, determine whether the function has a minimum value or maximum value. Now you can tell this is A, this is B, and this is my C. Now, according to this whole information, we know if A is greater than 0, we have a minimum because it's concave up. And this A is greater than 0, then it means the function has, f of x has a minimum value. There you go. Without graphing it, you can tell. Okay, now we have the same example, and I already know it has a minimum value. How would I find that value? Like that order pair, or the minimum value is always going to be a y value. So how do I find that? We're going to find the vertex. That's all we're going to do. We're going to have a x equal negative b over 2a. Right? That's how we find the x. So b is 16 and it's negative 16. So this negative and that negative, this is that negative, and I have negative 16 over 2a, which is 4. So this is going to give me 16 over 8, and it is 2. So my x value is 2. How do I get that y value, like f of negative b over 2a? I have to plug in this 2 in the original equation. When I plug in that 2, you can tell it's 4 2 squared minus 16 2 plus 1000. When I plug in all of that information in the calculator, I got 984. So what is my minimum value? 984 at x equal 2. You can write up here like that too. Minimum. And like I said, in calculus, that's how we find our absolute minimum. Minimum calculus AB, minimum value is 2984. So this is my order pair that I have, which means 984 is a minimum value at x equal 2. That's how you are going to say it. Okay. Now, we already know the quadratic equation domain is always negative infinity to positive infinity, right? If for example, if I graph this equation, like for example, that's my vertex is 984 because where the minimum and maximum occurs, and this is gonna be like a parabola like that. So this vertex is 984, right? And that's my minimum value. Now, you know, every quadratic has a domain negative infinity to positive infinity. That's it, because I'm starting from this negative infinity, I go positive infinity. What is the range? Range is going to be 984. Range means y value, so I'm starting y value 984 to positive infinity. So 984 to positive infinity. That's my range. That's how you find for the quadratic. Okay. Let's see, I have a word problem now, the one we're going to work on, which is this one. You have 120 feet of fencing to enclose a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. What is the maximum area? Now, in this case, the first step first, figure it out. Decide what must be maximized or minimized. So in this case, like that's the first step, okay? The first step is decide what must be maximized or minimized. So in this case, we know maximize the enclosed area. So area in this case, maximized. I'm just going to write a few words, maximize. So this is the first step. This is what we know. Second step, find out, express any quantity as a function in one variable. Like I would say, in this case, I am going to say, area of rectangle is A equal x, y. And we have a perimeter is 120 feet of fencing feet. So what is the perimeter formula? Because we know that in order for me to get the x and y, I am using my perimeter because this is only another information they're giving me in the question. So I have to use a perimeter formula in order for me to get the x and y, so I can plug it in here and find the area. So let's find the perimeter formula. Since it was a rectangle, they said, so I can say, okay, this is y, this is x and x. So perimeter means you add all the sides. So I have 2 x's and I have 2 y's. P is equal 120, 2x plus 2y. Now, what else I can do? So I can get the x and y's. So what I'm going to do, I will get the y by itself because I always do y by itself. So I'm going to do the y by itself in this case. So it's going to give me y equal 120 stays minus 2x. I moved that 2 up here on this one, so it's subtracting. Let me do it step by step. Okay, first let's do, that's 2y, subtract 2x. So I'm going to subtract 2x both sides, cancel. So I got 120 minus 2x equal 2y. Now you divide 2 both sides. So my y is equal 120 minus 2x over 2. I got the y by itself. Now I can solve this further, like I can separate the fractions like this. They cancel and this is going to give me 60. So technically I got 60 minus x, and that's my y equal. Now I have something up here for this area like a y value, so I'm going to plug in that y value, this y value in here. So x and 60 minus x, a equal 60x minus x squared. Or we can write this in order. The greater exponent goes first, plus 60x. So that's my area formula. Now this is in ax squared plus bx plus c form. So now let's figure it out how we are going to find the maximized area. So you know, maximize area means I have to look for the maximum, like I know it's going to be like this, right? So this is my maximum. It's concave down and it's maximum. So let's find the vertex first. Negative b over 2a, which is going to give me, b is 60, negative 60, a is negative 1. So negative 60 over negative 2 is going to give me positive 30. All right, here's the positive 30. Now, so we are looking for the dimensions so we can find how the this thing is going to be. So we plugged in that we're going to plug in this 30 to get the y value. So I'm going to plug in that 30 in my equation that I have, which is a equal negative x squared plus 60x. Plug in that 30 here, right there, and I am getting 900 when you plug this in the calculator. So this is what I'm getting for the area. So because they are asking for the maximized area, and this is my area for that rectangle. And what I did, I figured out the x, which was the vertex negative b over 2a. If it's maximized, and it means it's concave down, and I can tell it's concave down from this negative sign for the a less than 0. So I needed this x, and I got this x right there from negative b over 2a, which is 30. I plugged in the 30 for the x. I don't need f of f negative b over 2a. I don't need a y value for this because this is only x I have here. So I plugged in 30 here and it gave me 900. So this is my maximized area, 900 square feet. Okay, if you guys have any questions, please comment below. I will help you out. Like, share, and subscribe. Thank you.